All right, welcome back. Today we're going to tackle something that, it can seem a little intimidating at first, but trust me, it's the key that unlocks pretty much all of higher math. I'm talking about basic algebra. We are going to crack the code on one-step equations. Let's get right into it. So really, what is the secret to solving for x? I mean, you see a problem with a letter in it like this. What's the one thing you absolutely need to know to find the answer? Well, guess what? That's exactly what we're here to figure out. Okay, before we solve a single thing, we've got to get our heads around the single most important idea in all of algebra. We're going to call it the golden rule. And for good reason, because it is the foundation for, well, everything. I want you to think of an equation like a perfectly balanced scale. You know, one of those old-timey ones? The equal sign, that's the pivot right in the middle. Now, if you add a little weight to one side, what happens? It tips, right? So to keep it level, you have to add the exact same weight to the other side. Same goes for taking weight away. That right there is the golden rule. Burn it into your brain because honestly, it's the only tool you're really going to need today. All right, theory's great, but let's put that rule into practice. Welcome to level 1. Here, we're going to grab our first tool from the algebra toolbox, division. Okay, this slide lays out the perfect game plan. So we've got our problem, 3x equals 15. So what's the goal here? The goal is to get x all by itself on one side of that equal sign. But right now, it's kind of stuck. It's being multiplied by 3. So how do we undo that? We use its opposite, its inverse operation, which is division. So we divide the left side by 3, but wait, remember the golden rule? To keep that scale balanced, we have to divide the right side by 3 as well. So 15 divided by 3 is 5. And there it is, x equals 5. You can even check it, right? 3 times 5, yep, it's 15. See how that pattern just works? It's awesome. Let's try another one. 10c equals 90. We just apply that golden rule again. Divide both sides by 10. The 10 on the left just cancels itself out. 90 divided by 10 is 9, and boom, we find out that c equals 9. See? The rule just works. And hey, don't let it throw you if the variable is on the other side of the equation. It makes literally no difference. That scale is still balanced. Take a look at 20 equals 5d. To get d all by itself, what do? We just divide both sides by 5. 20 divided by 5 is 4. So d equals 4. This rule is totally universal. Okay, nice. You've totally mastered level 1. So let's level up and see how this all builds on itself. We're going to flip the script a little bit and use the opposite tool for a different kind of problem. So the really crucial thing here is knowing which tool to grab for which job, right? We just saw that to undo multiplication, we use division. So it just makes sense, right? To undo division, we're going to use multiplication. They're what we call inverse operations. They're literally designed to cancel each other out. And this slide shows it perfectly. Look at this equation. A divided by 2 equals 3. Our variable a is kind of trapped in that division problem. To set it free, we do the opposite. We multiply the left side by 2, which just, poof, cancels out the division. And of course, to keep our scale balanced, we have to multiply the right side by 2 as well. 3 times 2 is 6, so a equals 6. Simple as that. Let's try it with some bigger numbers, just to prove the point. 20 equals r divided by 10. How do we get r alone? We undo that division by multiplying both sides by 10. On the right, they cancel out. On the left, 20 times 10 is 200. So r equals 200. I'm telling you, this rule works every single time. Okay, you've got the core mechanics down solid. It's time for the boss level. This is where we go up against the numbers that can sometimes look a little scary, zeros, decimals, fractions, and we're going to prove they follow the exact same rules. They're not so tough. Let's knock out these so-called special cases real quick. If 6 times some number is 0, well, that number has to be 0, right? There's no other way. And if 5 times a number is 5, that number has to be 1. Your gut instinct is totally right on these, and it just goes to show that the golden rule still holds up. The system doesn't break. And what about decimals? Please do not let them intimidate you. The process is 100% identical. Just look at 4x equals 0.8. What's happening to x? It's being multiplied by 4. So what do? You guessed it, we divide both sides by 4. And 0.8 divided by 4 is 0.2. Done. See? Decimals don't change the rule one bit. And now, for the final boss of this level, fractions. Yeah, I know. But to defeat them, we have a secret weapon. It's called the reciprocal. It sounds kind of fancy, but all it means is the flipped version of a fraction. So the reciprocal of 2 over 3 is just 3 over 2. This little trick is unbelievably powerful. Let me show you why. Okay, here's where the magic happens. To solve this problem, 2/3 x equals 18, we just multiply both sides by that reciprocal, 3 over 2. And watch this. On the left, the fractions completely cancel each other out, leaving our x all alone, which is what we wanted. On the right, we do the math. 18 times 3 over 2 is 27. It is by far the cleanest, easiest way to handle fractions in these equations. Wow, you've cleared every level. You've mastered the golden rule, you've taken down the boss numbers, so let's head to the final challenge and see how this one simple skill is actually the building block for solving much bigger, more complex problems. And here it is. The question isn't just solve for x anymore. This is a two-part mission. First, they tell us that 9x equals 36. Then, we have to find the value of 2x. This is where our new skill stops being a trick and starts being a tool for solving a bigger puzzle. So, what's our first move? We have to solve for x. We got to use that first piece of information, 9x equals 36. Time to use our golden rule. We divide both sides by 9 to get x all by itself, and 36 divided by 9 is 4. Okay, so now we know x equals 4. But wait, we're not done. The question asked for the value of 2x. Now that we've cracked the code and we know for a fact that x is 4, the second part is super easy. We just plug that 4 in for x. So 2 times 4 is 8. And just like that, you solved a two-step problem. That is fantastic. So let's go all the way back to our original question. What was the secret? It was never about memorizing a million different rules for a million different numbers. The secret was just one single powerful idea. You always have to keep the scale balanced. You now hold the fundamental key to pretty much all of algebra. For real. You've proven that you can handle any number they throw at you just by applying one simple principle. So the only question left is, now that you've cracked this code, what are you going to solve next?